In rudimentary level of science, you've learned that there are particles called atoms that compose everything, including the screen, your clothes, and your body. However, as you got older, you learned that atoms are made up of protons, neutrons, and electrons. But what are those made of? The standard model of particle physics gives an answer to this question. If you keep on zooming in on any matter, you will find 12 universal particles and 5 force carriers. These 17 pieces are fundamental, meaning that they cannot be broken down into other smaller parts. They are categorized into 3 groups according to their characteristics: the bosons, leptons, and quarks. The force carriers, which are bosons, have no restriction on the number that can occupy the same quantum state. They have an integer spin, meaning that they have an integer angular momentum. They carry out the interactions between matter. There are 4 fundamental interactions: strong force, electromagnetic force, weak force, and gravitation. Gluon is a mediator of strong force, keeping protons and neutrons together. Now, gluons possess a property called color charge. There are 3 types of color charge: red, green, and blue. Each charge has its antiparticle counterparts. Think of it as a mirror image. Through the combination of these colors, gluons have 8 total color charges. The photon is the mediator of electromagnetic force, keeping electrons tied to the nucleus. The W and Z bosons carry out the weak force, decaying the neutron. Gravitation is carried out by the hypothetical boson, graviton. The 5th discovered boson, the Higgs boson, helps determine the mass of matter. The interaction of the aforementioned bosons with the Higgs field adds mass to the particles. Photons must interact across large distances, so they have no mass. The W and Z bosons are massive, so they can only act over small distances. Each of these bosons has its antiparticle counterpart, and some of them are identical to the original particles. Leptons and quarks make up matter. They are grouped as fermions, particles that have half-integer spin. Unlike bosons, only one fermion can occupy a particular quantum state at any instant. In this group of particles, the electron, electron-neutrino, and up and down quarks make up all ordinary matter. For the most part, the rest existed only in the early moments after the Big Bang. There are 6 types of leptons: electron, muon, tau, and their neutrinos. The electron is the fundamental particle of all atoms. It has a charge of -1 and is the only stable lepton along with their neutrinos. The muon and tau are unstable, and their decay results in conversion to other particles. Neutron decay results in the brief production of a W boson and an eventual production of a neutrino. They all have their antiparticle counterparts. There are 6 flavors of quarks. The up and down quarks are the most common quarks, and they make up all normal matter. 2 ups and 1 down make up the proton, and 2 downs and 1 up the neutron. Up, tron, and top have a charge of +2/3, while down, strange, and bottom have a charge of -1/3. This explains the charge of protons and neutrons. Each of the quarks has its antiparticle. Most of them are unstable. Now, a quark is always found with at least another quark, forming hadrons. Hadrons are composed of quarks, which are bound by gluons and their strong force. There are 2 types of hadrons: baryons and mesons. Baryons are made up of 3 quarks, and they have half spin, so they are fermions. Mesons are made up of a quark and an antiquark. Pions and negative kaons are examples of mesons. They are unstable and have integer spin, so they are considered as bosons. According to the same principle, atoms with odd number of nucleons have half spin, and they are therefore fermions. Atoms with even number of nucleons have integer spin, and they are therefore bosons. Like gluons, quarks also possess color charge. Now, since gluons conserve and cancel out the color charges in other quarks, all hadrons have 0 total color charge. With these 17 pieces and the fundamental interactions as the rules, the universe is a gigantic board game, and everything, the moon, the earth, and the sun, is merely a resultant of their moves. The standard model is not complete yet, but it gives a profound explanation to the universe and everything.